So this section looks at some of our special binomial products. We have difference of two squares, and then we also have our perfect squares rules. So these can help us to expand a little more quickly without using FOIL. So this first one here is an example of one of our perfect squares. So you should be able to see that it takes this form for a minus b all squared. So the rule says square the first term. So z squared is just z squared. And then we take the product of a and b and double it. So a times b is negative 6z, and when I double it I get negative 12z. And then squaring the last term, negative 6 squared gives positive 36. And so that's how we can expand those without using FOIL in just one line. Using the same rule for question 6, square the first term, I get 3 squared is 9. Now I multiply these two terms together and then double them for my middle term. Negative x times 3 gives me negative 3x, and doubling it gives me negative 6x. Then squaring negative x gives me positive x squared. Oops, that's a squared there. Okay, so I can now write this out as convention requires us putting our highest power first down to our constant to give us x squared minus 6x minus 9 for our answer to that one. So for question 8, it's the same thing, but we've got a plus in the middle here, and we've got slightly more complicated a and b terms, but it's the same process. So squaring 2x gives me 4x squared. For my middle term, I multiply together my first and my last term, and then I double the result. So 2x times 5y gives me 10xy, and doubling that gives me a positive 20xy. For my final term, I square the last term in brackets. So 5y squared gives me a positive 25y. Notice that that last term will always be positive because we'll be squaring either a positive or a negative number, which will always give us a positive result. And I nearly forgot to put the squared on that there. So we get 4x squared plus 20xy plus 25y squared as our answer to number 8. Number 10, hopefully we recognise as being a difference of two squares. So I have the same terms in each bracket, but the difference is that one has a plus and one has a minus in between. If I have a problem of this type, I simply square the first term, and then I subtract the second term squared. So y squared is y squared, and 5 squared is 25, and it's always going to be a minus in the middle in the difference of two squares. This is a slightly harder one because it involves surds, but it's the same kind of process. So first of all, square that first term to give us x squared. Now because it's a difference of two squares, I know that because I've got two different signs in the middle there. It means I'm going to have a minus in the middle of my answer. Now I square my last term, and root 5 squared is simply 5. So fully expanded, I get x squared minus 5.